Alright, today we're going to look at velocity. This is still chapter unit 5 section 2. And what you really need to know is that you need to know what velocity is. And you could think about velocity in two ways. You have angular velocity and linear velocity. Now for angular velocity, let's say this is your circle, because you need to think about it in a circular form. And let's just say you have like an object here or something and it's moving along the circle. Right, let's say you know up until a certain point, you know some type of information. In this case, let's think about the angle. So you know the angle, how much that object move, and maybe you know the radius as well. And if you know the time, then you could figure out the angular velocity. And in other words, it's really the speed. And you could think about speed in the same way that you could think about linear velocity. Alright, so let's say the same object. So this object is really this object. Let's call it A. So that A is really this A. And let's just call where it ended up A prime. Let's just say you were to take this curved amount and just straighten it. So it's the same amount of distance. So let's call that A prime. This is linear velocity. Distance, let's call it distance D, over time if you knew the time. Alright, so one is like thinking about it on a circle and the other one is thinking about it straight. Both ways you could think about velocity as being speed. Let's check out this problem. A record is spinning at a rate of 27 RPM. This means revolutions per minute. So I'm going to draw my record. If a ladybug is sitting 10 centimeters from the center. Okay, so this is on the record. Let's say this is the ladybug. Let's call it L. Sitting 10 centimeters from the center. Find an exact answer for each of the following. What is the angular velocity of the ladybug in radians per second? So remember, it's spinning at 27 rotations per minute. But notice how they said they want radians per second. Alright, so the first thing I'm going to do is change the minutes to seconds. So I guess I'll just kind of like do that on the side over here. 27. I'm just going to put revs per 1 minute. Alright, per just means like fraction. You could think about it like that. So 27 revolutions per minute. And if you remember from algebra how to convert, well, you could just multiply by a version of the number 1, and that version is 1 minute, and I'm putting the minute on the top because I want my minutes to cancel. The units, that is 60 seconds. So the units cancel there, and you end up with 27 revolutions every 60 seconds. Now, usually we want a unit rate. So let's see. I want to know how much revolutions happen every 1 second. So let's just divide that 27 by 60. 27, let's clear all of that. 27 divided by 60. 0.45. So 0.45. Well, you know what? Should we change it to a fraction? Yeah, let's change it to a fraction. Math, enter. 9 over 20. So 0.45 revolutions per second, but we know that's the same as 9 over 20 revolutions per second. Right, for every 1 second, that is. What we need to know though, since we want to know the speed or the velocity, is not how many revolutions per 1 second, but we need to know how many seconds in 1 revolution. So I'm just gonna go back here. I'm looking at this, and I want, instead of 1 second, I want 1 revolution. So I'm just gonna divide the bottom by 27, right? Because to go from 27 to 1, you have to divide by 27. So whatever you do to the numerator, you do to the denominator. And let's, whoops, up for a second. Let's math enter that to get into a fraction. 20 over 9. Something. Yeah, I think I typed that in incorrectly there. Let's do it one more time. 60 divided by 27. And that's the same number. Math. Fraction. 20 over 9. Oh, actually, that's right. 20 over 9 seconds. Alright, those two are like reciprocals of each other, but okay, I'm not even going to go into that. This is for every 1 revolution, this is for every 1 second. Alright, so keep that in mind. So what is the angular velocity? So the velocity, angular velocity, is equal to the angle in radians, and in this case we want the full circle. All right, the full circle's angle is 2 pi. Now I should have noted that we want this in radians. So 2 pi, traveling 2 pi radians in 20 over 9 seconds. Alright, so that's 1 revolution. 2 pi radians. And that's how they wanted it. They wanted it in radians per second. And next you'll see they wanted it in centimeters per second. So we'll get to that soon. Alright, so let's simplify this thing. Now I'm just going to write it like this so you can see it. 2 pi. Now I'm just going to leave the units out. We know the answer is going to be in radians per second. Right? I just kind of like took that part out and I put it there. So 2 pi. Now you know divide. When you're dividing, you're really multiplying by the reciprocal. So instead of, I'm going to put 9 over 20 instead of 20 over 9. Now 2 into 2 is 1. 2 into 20 is 10. So that simplifies into 1 times pi times 9 is 9 pi over 10 radians per second. Alright, and you can see that that's the exact answer we have up there. So now we want to know the speed of the ladybug. And here's what we need to know. Speed is equal to the angular velocity times the radius. So the angular velocity is 9 pi over 10 times, and remember that velocity is in radians, so if we only knew what the measure of the radius was, then hey, we could tell how far it traveled per second. Okay, so the radius is 10 centimeters, and we could just cancel. Well, the 10 cancels with the 10, simplify I mean, and we end up with 9 pi centimeters per second. And that's the answer right there. After 18 seconds, how far has the ladybug traveled? Now if it's traveling 9 pi centimeters every second, let's multiply that by 18. So 9 times 18. I'm leaving out the pi because I'm just going to tack the pi on at the end. This is 162. And you can see we have 162 pi. Alright, so they want to know after 18 seconds what angle has the ladybug turned through in radians. Okay, so they want the angle in radians. Now, we know that after 18 seconds it went through 162 pi centimeters. So we can use the arc length formula. And we know that's equal to the angle times the radius. So 162 pi is equal to the angle times the radius, in this case is 10. Divide both sides by 10 and you get theta is equal to 162 over 10 pi. Divide the top and bottom by 2, and you get 5 down there. The pi stays, and we get 81. So 81 pi over 5 radians. You can see that that's the answer right there. A sling is being rotated at a rate of 114 revolutions per minute. So notice they're using minute here already. Given an exact answer, what will the length of the sling have to be? So this is my sling. This radius is my sling. This is where like the person is holding the string with the object attached to it. This thing here is the object attached to it, and it's being just slung around in a circular motion. What will the length of the sling have to be so that the speed of the object at the end will be 43 meters per second? So they're going to per second already. So let's see how many revolutions per second occur. So we know we have 114 revolutions per minute. So let's convert that to seconds. So 1 minute times 60 seconds. They cancel, so remember 114 revolutions every 60 seconds. Now, here's the thing. I kind of need to know how many seconds in one revolution. So what all I'm going to do is divide the top by 114, and then do the same thing for the bottom. Divide that by 114. So 60 divided by 114. And let's see if we could put that in, whoops, in fraction form, 10 over 19. So one revolution happens in 10 over 19 seconds. Okay, that'll be important, because we know that speed is equal to angular velocity times radius. Now we know that the speed is 43 meters per second, and the angular velocity is, well, we have one revolution happens in 10/19ths of a second. I'm sorry. Yes, no, that's correct. One revolution happens in 10/19ths of a second. So we could just say 2 pi radians happens in 10/19ths of a second. And what we're going to do is just multiply by the radius. Just to clean things up here a little bit, I'm going to remove the units. And let's just simplify this. Oops, I forgot to remove seconds. Let's simplify this whole thing. Alright, so let's multiply both sides by 10 over 19. So that will cancel with that. Multiply this side by 10 over 19. We end up with 430 over 19 is equal to 2 pi r. Notice that that's the circumference. Divide both sides by 2 pi. So the radius is equal to, now I'm going to write this out, 430 divided by 19. And dividing is really the same thing as multiplying by the reciprocal. So 1 over 2 pi. And I'm only doing this because they want an exact fraction. So radius is equal to 430 over 19 times 2 pi. 38, I should have known that. Let's see if we can simplify that. 430 divided by 38. And obviously I know we can, they're both even. And math, enter, enter. And we get 215 over 19. So the radius is equal to 215 over 19, and the pi is actually on the bottom. Let's type that in and see if we get that decimal that they have. 215 divided by 19 pi. And you can see that those two decimals match up. So I'm just going to leave that like this. In fact, I'm going to write it right here, 215 over 19 pi. If the sling is 4 meters long, so now they're saying, if this was 4 meters, how fast will the object at the end be traveling? Okay. So again, we're going to use the same formula. Speed equals angular velocity, and we already know that that's 2 pi every 10/19ths of a second, right? I'm just kind of using this again. Times, and now we know, we're assuming the radius is 4. So I'm just going to remove the seconds there just to make things look nice. And instead of speed, we could think about this as x. And let's simplify. X is equal to 4 times 2 is 8 over 10 over 19. And I'm going to do what I did before. Dividing is the same thing as multiplying by the reciprocal. So that's 19 over 10. And 2 into 8 is 4. 2 into 10 is 5. So we end up with 4 times 19, 76. Don't forget the pi. 5 over 5. And that should be in meters per second. 76 pi over 5. Let's check it and see if we get that crazy decimal. 76 pi, 76 pi divided by 5. And you can clearly see that it's the same number. Okay, last but not least, a hamster running in a wheel of radius 13 centimeters. Let's see if I could draw it here. So the radius is 13 centimeters. Spins the wheel at 25 revolutions per minute. Again, I'm looking at the units. What is the angular velocity in radians per second? So 25 revs per 1 minute. Let's convert that to seconds. The units cancel, and we remain with 25 revs every 60 seconds. Right, and I could simplify that, but I don't think we might need that. What is the angular velocity? Okay, but what I will need is how many seconds in 1 revolution. So divide the top and bottom by 25. So just divide 60 by 25. We get 2.4. And let's change that to a fraction. 12 over 5. So it's 12 over 5 seconds. So 1 revolution happens in 12 over 5 seconds, or in other words, 1 revolution is really just 2 pi radians. So 2 pi radians, 12 over 5 seconds. Now that is the angular velocity, but let's simplify it a little bit. 2 pi times the reciprocal, which is 5 over 12. 2 into 2 is 1, 2 into 12 is 6, and the units remain the same. And you get 1 times pi times 5 is 5. And remember, this is all over 1, so 1 times 6 is 6. Don't forget the pi. Radians per second. And you can see that that's what we have there. at what linear velocity? So we want to take that and convert it to linear velocity now as the hamster running in centimeters per second. Okay, so we know that the radius is 13, so the distance around that entire circle is the circumference, which is 2 pi r, 2 pi 13 in this case. So that's 26 pi centimeters. That's the distance around the circle. So we know that the hamster could do 26 pi centimeters in 12/5 seconds. Remember, that's just one revolution. That's the same thing as this. This is what I used. One revolution in 12/5 seconds. And all I'm going to do is convert that to 1 second. So how do I go from there to there? I divided by 12/5. 12/5 divided by 12/5 is 1. So let's do the same thing for that 26 pi. 26 divided by 12. I should have typed that in parentheses. Divided by 12/5. Now thinking about that, it's 26 pi. And I just don't want it to turn into an irrational number, so I'm going to leave it on the side. Math, enter. So 65/6. So 65 pi over 6 every 1 second, and that is in centimeters. All right, so there you go. You can see that's the same answer as right there. Okay, well, that's it for this one. I'll see you on the next one.